Hey everyone, welcome to the FRQ solution series by Let's Unbound. So yes, we are back with another deep dive from the 2024 AP Calculus BC free response questions. In this video, we are tackling question 6, which is a Maclaurin series based problem. So let's see what the problem has and let's solve it step by step. Yes, no calculator. And the Maclaurin series for a function f is given by sigma n is 1 to infinity n plus 1 x power n by n power 2 6 power n and converges to f of x for all x in the interval of convergence. It can be shown that Maclaurin series of f has the radius of convergence 6. So series is given. It converges under the radius of convergence and 4 problems. So we will be solving this step by step. So basic description is given. And let's go with a problem. So for this, determine whether the Maclaurin series for f converges or diverges at x is equal to 6. So they clearly stated that it is convergent for all the x in the interval of convergence. So interval of convergence is 6 means. So for mod x less than 6, it will be convergent. But what happens exactly at 6? So this is convergent. We are checking about the convergence at the endpoint, right? So let's go with this. So it's very simple. You need to check at the endpoint. So just plug in. That's the thing. So plug in x is equal to 6 in the given series. Okay. So the given series is sigma n is 1 to infinity n plus 1 x power n by n power 2 6 power n. Okay, we can start plugging in sigma n is 1 to infinity in place of x, okay, not n plus 1 6 power n by n square into 6 power n, and do simplify this. So 6 power n will get cancelled out. That's a very simple and easy thing. And sigma n is 1 to infinity. Now I'm going to break down n plus 1 by n square. So you can write it into two series. N by n square is one series plus sigma n is 1 to infinity 1 over n square. Okay, so now simplified further for the first part. One is 1 to infinity 1 over n, and here sigma n is 1 to infinity 1 over n square. We can see a very familiar series here, which is this harmonic series. We know very well the harmonic series diverges. So you don't even want to think about the next. Next is actually P series, right? But still, so sum of two series, and I know very well sigma n is 1 to infinity 1 by n diverges because it's harmonic. Okay, now sum of two series, if one diverges, then the entire sum diverges. So hence the entire series diverges. What is entire series? Basically go to the root, series diverges. The root is the main given series, the Maclaurin series. So sigma n is 1 to infinity n plus 1 x power n by n square 6 power n diverges at x is equal to 6 at the endpoint. So this is the conclusion of the first problem, and you have to show all these work in a step-by-step manner. I hope this is understandable, and we are moving to B part. It can be shown that f of negative 3 is sigma n is 1 to infinity n plus 1 negative 3 whole power n square e power n. Sorry, 6 power n, and which is equal to sigma n is 1 to infinity n plus 1 by n square. They just simplified that minus half whole power n. And that the first three terms of this series sum to S3 is also given. We need to show this. Show that f of minus 3 minus S3 is less than 150. So when you see this, okay, many information is given. We are not going to calculate that much, right? So they give S3, they give f of minus 3. We just want to see the subtract, and then absolute difference is less than 150. We need 1 by 50 we need to prove. Okay, so this is an alternating series. Based on n, it will be positive, negative, positive, negative. So it's an alternating series, and this is nothing but alternating series remainder. Okay, so f of minus 3 minus s3, it's an alternating series remainder. So something will strike our mind here. So what is that? This relation. So modulus absolute value of R3 will be less than magnitude of next term. Okay, or you might have learned like this. So this is the series, the error in the series, right? We will say error or so up to 3 terms. For the first 3 terms, if you find the remainder, there will be an error. So that component is R3, or we'll say modulus Rn is less than the next term is an plus 1. So one of the thing you might have learned, right? So we're going to apply this. What is an plus 1? This is already given. So I need to prove it's less than 150. So an plus 1 should be less than 150. Let's solve for an plus 1. An plus 1 means we are doing R3. So I need to check with A4. Okay, so what is A4? How can we find A4? Just plug in this series component. So AN is this. Yes. So this is my AN, which is provided here. I think this one is quite simpler to take. Okay, so that minus will go for alternate plus or minus. So I'm going to take n plus 1 over n square half n. So you might think where that minus, it's alternative plus or minus. Okay. So alternating series after error bound, after 3 terms is what we have listed here. So this is alternating series error bound after 3 terms. So that's what we're going to do. So A4, we need A4 equal to, just plug in 5 over 16, 1 by 2 whole power 4. And simplify this, 5 by 16 times 1 by 16, which is 5 over 256. Okay, so my modulus error bound is minus f of minus 3 minus s3 is less than A4. A4 is 5 by 256. But what I have to prove is it should be less than 1 by 50. Okay, so this is equal to, when you divide this, it will be approximately 5 by 56 is approximately 0.0195. So when you compare this with 1 by 50, which is what we need to prove, will it be greater than or lesser than? So 1 by 50 is actually 0.02. This is 0.019. So of course this is lesser than. So I got it. This is lesser than 1 by 50. So finally we prove this. So yes, the error bound is less than 1 by 50. Right, that's a B part. And moving to C. The general term of the Maclaurin series for f dash, the derivative of f, we need to find it. Find the radius of convergence of the series for f dash. It's very simple differentiation. So what is your f of x? The given Maclaurin series, which is sigma n is 1 to infinity n plus 1 x power n by n square 6 power n. You start differentiating with respect to x. So f dash of x is going to be sigma n is 1 to infinity n plus 1 by n square and also 6 power n. They are like just constants multiplied. X power n alone we will do. N into x power n minus 1. And simplify, like this will get cancelled out, right? So we will get sigma n is 1 to infinity n plus 1 by n into 6 power n into x power n minus 1. So this is what we got. And this is f dash, f prime. Find the radiance of convergence of the Maclaurin series f prime. So radius of convergence of f prime is same as f. Okay, the derivative will not change the radius of convergence. So it preserves. F prime has same radius of convergence as F. Right? So that's it. We need to find general term. That's over here. They ask general term, but we differentiate series anyways. So the general term of F dash is n plus 1 n into 6 power n into x power n minus 1. We need to find radius of convergence, and that is 6. The same radius of convergence, which is given in the question. Right. So that's simple. Now, so this is all about part C. Moving to the last part, part D. Let g of x equal sigma n is 1 to infinity n plus 1 by n square x power 2n. So this is some other series that we can see. Use the ratios test to determine the radius of convergence of Maclaurin series for G. Okay, so first let's take the general term. Because ratio test, how will you apply? So you need to take this ratio, absolute value of an plus 1 by an. We need to solve this and then we will apply the test. So this is the main important thing. So what is an here? N plus 1. So sigma an, that's the rule. So all the thing over here. N plus 1 by n square into 3 power n into x power 2n. Okay. Right. So we need to simplify. So ratio test is an. What is an plus 1 that we need? So every n should be replaced with n plus 1. So here n plus 1, n plus 1 plus 1. Okay. Then divided by x power 2 into, use the bracket and put n plus 1. And n square will become n plus 1 the whole square. 3 power n becomes n plus 1. So do it carefully. And simplify it, n plus 2 into x power 2n plus 2 divided by n plus 1 the whole square, 3 power n plus 1. Now coming to this ratio, an plus 1 at the top, an at the bottom, equal. So write it first, n plus 2, x power 2n plus 2 divided by n plus 1 the whole square, 3 power n plus 1 times, this should be reciprocated because an, we need 1 by an. So n square will go to the top, 3 power n, then n plus 1 into x power 2n, and simplify this. Okay, so what can be cancelled out? 3 power n, 3 power n plus 1. So when you cancel out, 1, 3 will be in the denominator. N plus 2 we can't cancel, so n plus 2. X power 2n plus 2, x power 2n. So when you divide them like x power 2n, x power 2n cancelled, x square will be there. Divided by n plus 1 the whole square and n plus 1 will become n plus 1 the whole cubed. And yes, as I said it, if you combine this, you will get 3. So this is what we got, which is modulus okay, n square is there, I forget about it. N square is also there. So n square into n plus 2 into x square by 3 into n plus 1 the whole cubed. Okay. Now we're gonna, in the ratio test, you will apply limit n tend to infinity, not for x. So x square by 3, you can take it out and limit n tend to infinity for this n square into the n part. 3 into n plus 1, n plus 2 whole cube. So this will become 1. Okay, this 3 will not come. It's outside. So they are very closer, right? N square you can treat as n plus 1. Just we are adding 1. And here you can subtract 1. So this will be approximately, they will get cancelled. So if you simplify them, you can, like, you can just adjust them in this way by n plus 1 the whole cube. And above also n plus 1 whole cube cancelled. So it will be just 1. Okay, since n is approaching infinity, just adding 1 will not make that much effect. So it's something around 1. So it will be just treated as 1. So we got x square by 3. Okay, what is the ratio form. And okay, so let me solve here. So modulus x squared by 3 should be less than 1, right? And x square should be less than 3. Like if you simplify, this implies mod x is less than just absolute value thing. So the equivalent, if you write, this is the radius of convergence structure. So radius of convergence for G is root 3. This is all about. So ratio test, an plus 1 by an, we simplify and we apply limit n to infinity, it becomes 1. So as per the ratio test, x squared by 3 modulus should be less than 1. And we solve for x because we need the radius of convergence. So we should make a structure like modulus x is less than what? That number is radius of convergence. So we got, okay, here we just manipulated it and we got a C. So this is about part 3. Okay, right. So this is the rule we are applying. Why we are saying it's less than 1 means by the ratio test, the given series will converge if your result that an plus 1, okay, by an, if it's less than 1, it will converge. So that's why we are giving less than 1 and we are solving further. Right? Yes. So that's the wrap for this video. Yes, it is a series-based question. And yes, in series, we can come across lot of tests. You might got confused with the name of the test, but keep practicing. You will get to use. So just by looking at the series, you will able to identify what test to be applied and all. Right. So if you find this walkthrough helpful, give the video a like. You can subscribe to the channel and don't forget to check out the full playlist. So we are solving every FRQ from the 2024 BC exam just for you. So if you want a real-time help and community support, join the Let's Unbound WhatsApp community using the link in the description below. So we are building a space just for serious AP calculus learners like you. See you in the next video. Thank you for watching and learning with us.